Linear Regression in RStudio Part 2. This video is a continuation on my previous video about linear regression in RStudio. Watch that video first to understand the basics of linear regression in RStudio. This video covers interactions between variables, powers of variables, and categorical variables. For this tutorial, the data used is the same as the first video, so use the same code to import it to RStudio. The first topic we are going to talk about is interactions between variables. This model is used when you think that the explanatory variables have an effect on each other. The formula of this model will be something like this, and the code to build this model will be something like this. There are two ways to build this model, either using the colon sign or the asterisk sign. Either way, both of them will give the same result. Now, you will be very familiar with the output if you've watched the first video. Next, we are going to discuss power of variables. Use this method when you think that the relationship between the explanatory variables and the target variable has a curvature relationship. The formula will be something like this, and there are two ways to build this model. The first one is to simply square the explanatory variable when building the model, or the second one is to create a new column which has the squared values of the explanatory variable, then build the model using the newly created column. Again, the output will be very similar. Next, we are going to talk about categorical variables as explanatory variables. The dataset now has two additional columns, cat1 and cat2. First, we create the list, then we insert the list to the data frame. Next, we need to make sure that the categorical variables are recognized as factors by running this code. Notice that while the values of cat2 are 0, 1, and 2, we treat them as categorical variables and not numerical variables. Alright, first we're going to build a simple model with cat1 included in the model. The code to build the model is as follows, and the result will be something like this. Notice the red box. This shows that the variable in model 5 is called cat1b. The way to interpret cat1b is as follows. The formula will have the form like this, where x3 will equal to 1 if cat1 equals to b, and 0 if not. In this case, the value a from cat1 is called the base level. The variable x3 is actually called a dummy variable. So now, the estimated model will be something like this. So, how do we use this model? Let's say we have x1 equals to 0, x2 equals to 3, and cat1 is a. Since cat1 does not equal to b, then x3 equals to 0. While if cat1 is equal to b, then x3 will equals to 1. So, that was the model when the base level is a. But what if we want a base level to be b? To do that, we use this line of code. The first line basically tells RStudio that we want the base level to be b instead of a. And the results will be something like this. So, how about categorical variables with three categories? The code to build the model is basically the same, however, the results will be slightly different. Notice the red box that it contains two different variables, cat21 and cat22. The way to interpret cat21 and cat22 is as follows. The formula will have the form like this, where x3 equals to 1 if cat2 equals to 1 and 0 if not, and x4 will equal to 1 if cat2 equals to 2 and 0 if not. In this case, the value 0 from cat2 is the base level, and the estimated model will be something like this. Notice that there's a pattern here. When the categoric variable has two categories, there will be one dummy variable. Three categories, they will have two dummy variables. Therefore, if you have a categoric variable with k categories, you will have k-1 dummy variables in the model. Keep in mind that you can also apply interaction to categorical variables to get this ridiculous mess. Thank you for watching. What do you think? Which technique is your favorite? Leave your comments and I will definitely read them. Please like and subscribe if you find this video useful.